Good afternoon, everyone. I'm going to perform the balancing equations. A couple of things you're going to need is a dry erase marker. Uh, you're also going to need 8 red 4-prong atoms, 4 blue 4-prong atoms, 6 green 1-prong atoms, 4 yellow 1-prong atoms, and 20 white 1-prong atoms. So let's go ahead, and I have taken pictures to show that that's separated. So let's move right on into activity 1. So I'm gonna pull this down so you can see what I'm doing there. Okay, so it says with the wet erase marker, write 5 colors: red, blue, green, and yellow, and white on the model pieces in the color column of the tally table of balancing equations. So we're gonna do that. We're gonna write red, blue, green, yellow, and white. Okay, it says still using the wet erase marker, write the symbol/formulas for the reactants and products of the first equation from the laboratory questions on the balancing equation mat. So you will need to have up your balancing equation pre-laboratory experience. So the one I would like to do is going to bring it up just a little. So we're going to write NaCl BeF2 NaF BeCl 2. So I just want to show you that that's done. That's written there. Hopefully you can see that pretty well. Okay. Okay, so we're going to assign a different color to each of the atoms in the equation in the symbol column of the tally. So let's do that. So for Na, we're going to assign it to red. For Cl, that will be blue. For Be, that's assigned to green. And for F, that's assigned to yellow. Okay, so in the reactants, we have red, so we're going to put 1 red 4-prong modeling set there. And then for Cl, we're going to use blue. Be is going to be green. And we have 2F, which we assign to yellow. One, two. And then as far as the product, we have 1 Na, that's a red, and actually only 1 F. So as you can see, just by looking, this really helps me as far as a visual representation, because you can already see that over here in the product that you're missing 1 yellow, which is F, and you're also missing a Be, which is green. But let's go ahead and finish this out and see what we end up with. We have 1 Be, and then Cl, we have 2, which is blue. So we have 2 in the product. Okay, so let's go ahead and do what it tells us to do. So over here we have how many NAs? We have 1 Na. Blue, we have 1. Green, we have 1. And of the F, we have 2. Do the same thing. Do the same thing on the product side. So of NAs, we have 1. of the blue, we actually have 2. Of the BE, I'm sorry, yeah, of the CL we have 2. Of the BE, we have 1. And of the yellow, we only have 1. So as you can see right now, this equation is not balanced. We have 2 CL over here, we only have 1 over here. Same thing over here. In the product, we only have 1 yellow, which is F. So now we need to balance this equation. You can do that by, for the NaCl, if we put a 2 here, then that also means, so let's kind of go back and do it step by step. So we have 2 Na, which I need another red, so I'm going to add that here, and 2 Cl, which is the blue, so I'm going to add another blue one. Now if we do over on the product side, if we also add 2, so 2 Na, the NAs are red, so we're going to add one more. Already we can see that this is balanced. There's 2 Na in the reactant as well as 2 Na in the product, so that there is showing your balance. Also, there's 2 Cl, there's 2 Cl, both in the reactant and the product. So let's keep on going. There is 1 green in each side, so that's balanced. But what about over here with the F? Now, since we put a 2 in front of that, we can add 1 more F, and then therefore our equation is actually now balanced. As you can see, a good visual representation of that.